I've done a video on the number 2 practice problem in this. I called it chapter 3 in class, I guess because I didn't have practice problem doing regression results, but there's a couple of PDFs about running regressions and other videos about doing that. So I have a video, I think, on question 2, and I called that, well, I think that was video number 10 on my little playlist here. Module 2, practice problem engineers question. Again, that's the 10th video of the playlist. And this number 2 practice problem is about engineers and market researchers. But I don't think we did I don't think I have a video going through how to do question number 1. So we can go ahead and do that. Obviously, the answers has it all filled in, and so that kind of gives it away a little bit. But why don't we just kind of use a brand new sheet and kind of start from scratch, because what I give you certainly is a start from scratch. So graph a scatter plot in Excel with Q on the horizontal and total benefit and total cost on the vertical. But I said first thing to do was to, again, make a scatter plot with Q on the horizontal. So I'll go in, I'll highlight everything, insert, got my little chart here, and I don't want to do the lines because I've got this gap in between the data. So trying to have these things with lines in them isn't going to get me very far. I'll just do the dots for now. I've got dots here. So I can see my total benefit set of dots is going to be the blue dots. The total cost set of dots will be the red dots. And I got to realize that for the quantity of 0 and for the quantity of 90, the total benefit and total cost are the same. So even though it looked like the red dot, it actually looks a little purple on my screen, but the red dot is the one that's in front on my picture. But there is a blue dot behind that one. So, okay, graph a scatter plot in Excel with Q on the horizontal, total benefit, total cost on the vertical. Make a prediction as to the Q that provides the largest net benefit. So the net benefit, again, is going to be the difference or the distance between these two. And all I have is just a few points here, but I can kind of see the pattern that seems to be happening. Again, there's a blue dot down here, and there's a blue dot up here too. So if I kind of think visually how this is going to trace itself out, I've got a line that seems to be going, this sort of a shape to it. So here's my total benefit line for that. Total cost, again, sort of has, an inverse sort of a shape. Connect all these dots here. If I just think visually, or like I says, make a prediction as to the quantity that provides the largest net benefit, I would guess, actually, it looks like right around 50 is probably where it would be the biggest. I mean, it may be at 40, but those still look some a little bit closer together. Maybe around 60 might be a little close together. Or even, maybe 55 or, 55 would be over here. Even this set of dots that I have here is probably going to be pretty close just by eyeballing it. This looks like it's probably going to be the farthest apart. Although there may be some, a little bit to the left of it or a little bit to the right of it where the net benefit may be the biggest. That would be my prediction for number 1. Part 2, click on a dot in the graph to highlight the series. And I want to do a trend line. So I can either do that and click on a dot, and I've got this add trend line button here. I could also, if I'm highlighting the blue set of dots, I can go to design, add a chart element, and I've got trend lines there too. Add trend line. I got these options here, and I said to do a second order polynomial. So the default is just this linear, this straight line, and that's okay. It certainly doesn't hit all the dots very closely, especially the beginning and the ending ones. But if I do this second order polynomial, so it's a polynomial of order 2, and at the bottom, mark the box for display equation on chart. So I think I probably talked about it in the video somewhere that a polynomial of order 2 is what we call a quadratic equation. It's got a x variable and an x squared term in there, and it fits it pretty much perfectly. I could do the r squared also. I got an r squared of 1, so it's basically fitting each of those lines exactly. This particular equation is creating a line that hits through each of these dots exactly. So it does a perfect job of explaining it. Do a trend line for both total benefit and total cost. So here's my total cost set of dots, and I'll do it the other way this time. Instead of right-clicking on a dot and doing the add trend line way of doing it, I will have all my dots clicked still, and I'll go up to design. Well, it's already selected. Add chart element, trend line. And there's nothing really here yet. I mean, I don't really want the linear, so I'll just go to more trend line. It doesn't have second degree polynomial in this list right here. So I'll go to more trend line. Same sort of options over here. And again, I don't want a linear. I want a polynomial of order 2. Display my equation. I got to remember to move that. The r squared again equals exactly 1. So I'll do that, and I'll move this down here just so we can keep them straight. Okay, so I've got 2 equations here. And again, the way that I would look at this is my total benefit equation. I could say instead of using y's and x's, I could say total benefit equals blah, blah, blah times q squared plus 1.8 q, and this number is basically 0. And down here, total cost equals 0.009 q squared plus 0.09 q. And again, this number is very small also, so I could basically call that 0 as well. Use the trend line equations to fill in the remaining values in the table. So I could say, again, we've got these gaps here that nothing is showing up. So I could go, okay, so this total benefit, again, this equation that I'm using here allows me to make a prediction of what the value of total benefit is going to be. And actually, I know it's going to be exact because the r squared is exactly equal to 1. So if I say total benefit equals negative 0.01 times q squared plus 1.8 times q. And again, this negative 3e to the negative 13, this is actually 0 point, and then there's 12 zeros, and then a 3 at the end of it, so it's very, very small. So I'm just going to not bother putting the 0. I'll just to make everyone be okay with it, I'll just put minus 0, since this 3e to the negative 13 is basically 0. So here's my total benefit equation. For my total cost, I'll do the same thing, 0.009 times q squared plus 0.09 times q. And again, this 2e to the negative 13 is really small, so I'll just say minus 0. I mean, you don't have to have the minus 0 in there, but. And so you see what happened when I put these formulas in here. It created these 2 dots. Again, this used to be blank, and now there's no dots there. But when I went in and put the formulas in there to predict the values of total benefit and total cost, it put those dots in there. And so I'll just go in, since my formulas are referring to the values of q, so I've got, instead of doing 0.01 times 10 plus 1.8 times 10, I multiplied it by the cell, so cell A3, 1.8 times cell A3. And I didn't use the dollar sign. So if I go in here and I can copy this and just go here and paste, paste, paste. And you can see it, as I did that, it's adding all those dots to the rest of my little fish-shaped thing here. And again, if I were to click in like a quantity of 60, that was one of my blanks from before. I can see, it still basically has the same equation. Now it's referring to this quantity of 60. Same for the total cost part of it. And I'm getting these values, and I can see, again, where those dots are lining up. Okay, so use the trend line equations. We did that. Create a net benefit column. So net benefit is the total benefit minus the total cost. And I think I'd mentioned this before. I could go in and retype that formula every single time. But a quick way of doing it is either I could copy this, highlight the rest, and hit paste, and it'll put them in there. Or if you don't even want to do that, you could highlight here, and there's a little small box that shows up in this lower right corner. If I hover over that and then double click that, it copies everything down to where there's no data anymore. So let's see, I did that, create a net benefit column, and again, make a prediction for the optimal Q. Well, it looks like the highest net benefit was at both 40 and 50 and get 38 units, or 38 units of happiness, I guess. So between 40 and 50, so somewhere in here, well, I mean, I get the same amount of net benefit here as I do here. Well, you might think that is 38 the most benefit you can get? I mean, would you be equally happy producing at 40 or producing at 50? And I guess, if I phrase the question that way, are you equally satisfied producing at 40 or 50? Then I'd say, well, yeah, but I could probably do better than 38 units of happiness. I could probably do better than that. Because, I mean, again, just the way these curves are shaped, that, okay, I get 38, the difference here is 38, the difference here is 38, but somewhere in between, the difference is probably greater than 38. And I might just make a guess and say somewhere around 45 probably is going to be where the net benefit is the biggest. Use calculus to find equations for marginal benefit and marginal cost based on the trendline equations. Okay, so let me type some of these out then. So just a kind of quick recap of what these equations are. So this says use calculus to find equations for marginal benefit and marginal cost. Let me bump this down a little bit. So the marginal benefit would have to be 2 times negative 0.01 q, and it would be, well, I could put q to the first, but anything to the first power is just itself, so I'll just leave it like that. Plus, this is 1.8 times q. Well, if it's just the coefficient times the variable of itself, it would be like q to the first, and then I'd say 1 times 1.8, and then it would be q to the 0th, and the q would anything to the 0th power is equal to 1. So this just ends up being 1.8. So I could actually make this a little easier too and go negative 0.02 q plus 1.8. Then for the total cost part of it, to make a marginal of that, 2 times 0.009 q plus 0.09, or 0.018 q. Okay, so I've used calculus, I've found equations for marginal benefit and marginal cost. Graph a scatter plot with q in the horizontal and marginal benefit, marginal cost on the vertical. So I've got to take these things, these over here a little bit, and make marginal benefit and marginal cost formulas now. So my marginal benefit was, again, negative 0.02 times q plus 1.8. The marginal cost was 0.018 times q plus 0.09. It'll be a long video. Double click that, trace it all down. I've got my q's, and I've got to highlight these marginal benefit, marginal cost things. Scatter plot for this. So I have my marginal benefit line, which is downward sloping, my marginal cost line, which is upward sloping. So those should look similar to the marginal benefit, marginal cost curves you had in your chapter. Again, make a prediction for the optimal Q. Well, the optimal Q will be where these two lines cross. And it looks, again, that, well, if I were to plot these out, I could go in and throw it, and it's a straight line, so I could do some linear trend lines here. Well, wherever these two curves cross, wherever marginal benefit and marginal cost equal each other, that's going to be the optimum. So it looked to be, again, maybe around 45 in this graph of the marginals. And again, here in the graph of the totals, it also looked to be around 45. Solve algebraically. Well, I want to say marginal benefit equals marginal cost. So negative 0.02 Q plus 1.8 equals, I got to put a space in here, 0.018 Q plus 0.09. Doing the algebra on this. So let's see, I'll take the, when I did 1.8 minus 0.09, I got 1.71. If I do 0.018 plus 0.02, I get 0.038. So this little equation would be, well, this thing simplified. 1.71 equals 0.038 Q. It equaled 45. So if I set these two marginal benefit, marginal cost equations equal to each other and solve for the value of Q, I got 45. if I went up here somewhere and maybe inserted, shift the cells down, 45, and this already is just the way I did it because I had an equation here and down here, I guess, too. When I put in a quantity of 45 here, well, I can see these two are equal to each other. So I could verify it that way, too. And, of course, when I did that, it made some dots in my picture down here.